Defining a way to rewrite a radical expression using rational exponents provides for us a tool in our simplifying and understanding process. We keep in our mind this rule that when you have real non-zero bases, and then we consider any other integers x, y, knowing that y in fact has to be greater than 1, that we can rewrite a radical as an expression with rational exponents or vice versa. This radical could be thought of in either order. So let's consider a couple of examples. In both the case of a and b, you will notice that there are rational numbers or fractions in the exponent location. Furthermore, you'll notice that there are no variables, so the directions for this would be to evaluate. We want to arrive at a number that looks simpler than what we see in front of us. We're going to begin with example A, noting that the overall term is negative, so we need to keep track of that. And then we notice that the exponent itself has a negative on it, and we recall that that means that this must be rewritten in the denominator. 3125 is the base, and we are going to write it as a radical indicating an index of 5, and the exponent is only 1. Not really recognizing 3125 as a familiar power, we will use our factor stack to start dividing by 5, the lowest prime that seems to work. Considering how we might rewrite that 3125, we examine our factor stack, or of course you could use the key on your calculator y to the x to do some experimenting. In either case, we do notice that that denominator as a radical is really the number 5 to the 1, 2, 3, 4, 5th power. We continue to notice that this is overall negative coming from the original problem, and that it exists in our denominator. Converting it back then to the rational form, we can put the index as the denominator and our numerator of 5, and we know from our fractions experience that 5 divided by 5 is 1, so in fact we have evaluated the original to be negative 1/5. For a second example, we have the base 256 being raised to the 3/8 power. Rewritten then in radical form, we have an index of 8 and a power of 3. Now in this case, we recognize that 256 is really 2 to the 8th power, and our exponent here tells us we need to write that 3 times. We recall that we can write these as separate radicals, and in so doing it becomes even more evident that the 8th root of something to the 8th power, or rewritten as a fraction, it helps to see that again our exponent 8/8 is in fact simplified to be 1. We're reminded we have 3 such terms, so in the final analysis we have 2 times 2 times 2, which is in fact 8. Certainly a simplification of 256 to the 3/8.